All right, so let's talk about memoization, which is a lot like memorization, but not quite. So the idea here is that I have this function that I'm going to call repeatedly, and each call depends on some kind of complex process or some math or something, and those calls take time. So my goal is to cache the most recent calls in case I need them again, so that I can just get them back. That way I don't have to go through the rigmarole of calculating again. So for this example, I'm going to use the Fibonacci sequence. So I've got my Fibonacci function. It's already written. I'm actually going to copy and paste it in here for reasons I'll talk about at the end. But let's just recall the fourth Fibonacci number is the third Fibonacci number plus the second Fibonacci number. And then the third Fibonacci number is the second Fibonacci number plus the first one. And the second Fibonacci number is the first Fibonacci number plus the zero Fibonacci number. So at this point, then I'd say, okay, so the second Fibonacci number, right? So if I wanted to say that this is equal to, and that first thing is these two again. So you'll notice I'm actually running into like size constraints. And then these are, this one's 0. So then these are 1 and 0 and 1 and 1 and 0. And that's a long dig, right? This is a lot of substituting. This is going to take forever. That's why when I get to like 35 on the Fibonacci sequence, it takes a long time to calculate. So what if instead of calculating Fibonacci of 1 a whole bunch of times, what if I just remembered that was 1? And then what if I remembered that Fibonacci of 2 was 1? That would make this a lot easier, right? So in order to do this, this process where we just remember what things are, the first thing we want to do is, let's see, should I wrap this up in a decorator? I'm going to wrap this up in a decorator. So I'm going to define a width, oops, memoization decorator for a function, right? And the way I'm going to do that is I'm going to define a function with memoization, or however you say this word. Okay, and one thing is I'm kind of expecting this to get some arguments, right? So I'm going to tell it to expect args and quarters. Okay, so what I'm going to do is before I define that function, I'm going to define a past results. Right, so that's going to be an empty dictionary. Don't worry that it's a dictionary, it doesn't really matter. You can just think about it as like it's like a list, but it's got different keys to it. Okay, so then I'm going to define my function with memoization, right? And that function's going to say, if the args are not in the past results collection, right? So in other words, if we haven't done this calculation yet, right, then we need to take past results at args, right? So we're going to say now we'll evaluate this thing. So we're going to take the function at the arguments and the keyword arguments. Okay, so this is me saying, all right, if we haven't done this calculation already, we'll do this calculation and then we'll store it into the past results, right? And then what we're going to do is we're going to return that thing we just stored it into, right? So we're going to return this stored results. This is maybe not the not the most efficient way to do this, but it won't matter because it's pretty damn efficient anyway. And then I'm going to return, right? And the thing I'm going to return is this function that has my memoization, right? Okay, so let me go get my Fibonacci sequence here, or my Fibonacci function here. So I just went into the file, and I'm copying this, and I'm going to paste it. And then I'm going to do something like, oh, what the heck? Let's print out Fibonacci of 100. Okay, so if I hit go, what do I expect this to do? Frankly, I expect it to kick a whole bunch of errors because I haven't type checked anyway. All right, so let's see the errors. Okay, so 1, it's hung, right? It's just calculating. 2, I have a whole bunch of errors. Okay, so those are imported, not used. Fine. Expected 2 blank lines, found 1. Expected 2 blank, no. That's a, I don't know what that one's about. That's an expecting 2 blank lines. What is this? No new line at the end of the file, okay. P.S. you can get it to relint if you just hit save. Okay, so I've still got a unused thing, so I'll just, oops. Just comment that guy out for right now. I've got a missing white space after, I forgot to hit space, and, okay. All right, so now we're all linted out, right? Okay, so now if I hit go, I still get no output. The reason I'm getting no output is I bothered to make this kind of memorizer thing, but I didn't use it for anything, right? So I claimed that I was going to make this more efficient, and then I just didn't do that. So if I want to add a decorator to a function definition, right? So I wanted to decorate the Fibonacci function. So I should add that decorator, and that's going to be with Memoization, right? And you'll notice I've been talking for a second here. It still hasn't resolved. We'll trash that. Let's try it now. Like I said, we'll trash that and try it now. Wait. That took literally no time at all. Okay, let me hang on. That's like scary fast, right? So let me say, all right, I'm going to import with my timer too. Okay, and I'm going to add my with timer decorator. P.S. If you want to add more than one decorator, you can just slap them on here. The order does matter. So let me hit run here, and then we'll see. All right, so notice I'm getting 2 calls, and it's telling me this took 1/10 of a second. If I take this thing and put it here, I probably get, see, I only get the 1 call, so the order does matter, right? And it takes about the same amount of time, and it's whining that, oh, it's whining, there's too many blank lines. Okay, so, bam, 4/10 of a second. Kick ass, right? So, or 4, not tenths, 4/100ths of a second. So, please remember, this thing, I never saw it before. I never knew what Fibonacci of 100 was because it took forever. Like, I mean, without the memoization, this is maybe hours of calculation. Okay, so let me show you the subtlety that took me most of the friggin' day to sort, well, not most of the day, but like an hour and a half or something to sort out. So do be aware those happen to me fairly often. Here, in full disclosure, is my Stack Exchange question. I'm gonna pull that over here just so we can look at it. So Stack Exchange is great. I submitted this at 46 minutes ago. Okay, so for Stack Overflow, if you're going to ask a question, just create an account, go ask a question, it's no big deal. People will actually answer them. I got helpful results out of this today. So This is roughly just like, hey, here's what I'm trying. Here's what I looked up. Here's a link to a similar but not quite the right thing question. So let me demonstrate one thing with this. In here, it is important that these guys are part of the function definition, or, right, because you could do this the other way. So the other way would be to create this function definition and then do Fibonacci equals with memoization of with timer of Fibonacci, right? Okay, so I'm gonna dump my console, hit run. Note, this works exactly the same way. If I swap these, the timer and the memoization, they'll just go in the other order. Doesn't really matter. The only thing is if you put the timer on the inside, then it doesn't give you that junk call that it took 0 seconds all the time. Okay, so this goes really, really fast. However, if you name this something else, like if you say fib is with memoization of with timer of Fibonacci, right? And then you run fib, it takes eternity again. And the reason it takes eternity again is when you call the Fibonacci function, right, which is really what you're doing in here, in the memoizer, you're calling the Fibonacci function. That's going to happen right here. You're not calling the memoized version because they have different names. So fib is a memoized version, right? It's got a memory. Fibonacci's dumb. It doesn't have a memory. So when you memoize just the outside, the interior calls don't have any memory. And so they take forever still, right? Because in the end, what this is going to result in is this is going to record one thing in its memory. It remembers that fib of 100 is this number whenever it gets it. It'll take fucking hours. But in the process, it had to calculate Fibonacci of 99. But it didn't remember that. Does that make sense? So the way to get around this, right, is to just make sure that it's got the same name. So, or to attach those decorators to the function definition. Either way. Right, so if I go back, now that it's got the same name, it's overwriting it. Now, if you look at my Stack Overflow question, my Stack Overflow question is related to importing this function. Because, right, this is dumb. I shouldn't have to have the Fibonacci definition in here. I should just be able to import it. Okay, so in the case that you import it, let me see. I'm going to do a file, save as, and I'm going to do memoization import. Okay, and then I'm going to change my description over here. Okay, so I'm going to, from the Fibonacci file, I'm going to import Fibonacci, right? And then I shouldn't need this definition because I just imported that, right? Okay, and then I'm going to do this. And now this should work in exactly the same way, right? Like, oops, let me go back. Okay, so I have my old version here. I just want to convince you that this is working. Okay, so I hit go, 1/10 of a second, done, check, awesome. All right, so now I'm going to replace this part that I copy and pasted. I'm just going to delete that. I'm going to leave the naming the same. And I'm going to just say, look, instead of copy and pasting it in here, go into the file, get it, right? Should work exactly the same way. 1, I have too much white space. 2, oh, come on, just freaking execute. It's hanging, right? That's because it's calculating. Why is it calculating? Why wasn't it smart? Well, that's what my Stack Overflow question's about, right? So if I go look at the comments I got, Andy, please stop the ball. Stop. Come here. Come hang out with me. Okay, so if you go look at Stack Overflow, you will see me asking, the imported one doesn't work. I did put an example one in here and ran a couple of things. Somebody responds to me that the problem with the imported thing is that it's looking it up in the module's namespace, not the namespace where I imported the function. Okay, that is totally true. I didn't know what the namespace should be to overwrite it, right? So I knew that it was importing it. I knew that it was thinking about it as part of a module, but I thought it, when you imported it as, right? So when I did my import, right? I imported the Fibonacci function. I thought that moved it into the namespace so that I could overwrite the name, but it doesn't. So the second comment is the one that I happened upon. I happened upon that solution right as this guy was writing it, which is that if you want access to its name, you just do import the module, right? So that imports the entire module, and then rename. Andy, please stop. Okay, so now this is taking the Fibonacci module, right? Getting the Fibonacci function out of it and relabeling that with the decorators on it. And then if I print Fibonacci dot Fibonacci of 100, oops, sorry, that was still calculating. Boom. 10th of a second again. Okay, so what should we learn from this? The moral we should learn from this is that importing things together, like pulling things from multiple libraries and sticking them together, is sometimes just a little bit more complicated than you would hope. Sorry, I needed this. So, Memoization is a super useful tool. It is killer cool because it lets you just record the results of hugely long like database queries and crap and store them locally. You use this all the time. This is how your web browser works, basically, right? Like, it has a cached version of websites, and so it just updates the things that have changed instead of getting the entire thing. So this is something that we use all the time to speed up kind of computation. The fun thing is that your brain also does this. So there's a bunch of these studies where if something moves around in your peripheral vision real slowly, you won't notice that it's moved. If the color drains out of your peripheral vision, you won't notice. All that shit's just cached. It's just memoized, and it doesn't update until you pay attention to it, right? It's like Minecraft blocks waiting for an update. They just hang in the air or whatever. So super, super useful, little bit complicated, tiny bit frustrating. The moral of this story is, if you don't know, ask on Stack Overflow. All right, guys.